Hello everyone and welcome. My name is Ryan Sigelko. I'm the Senior Vice President of Technology here at Hardline. I'm standing here in our Technology Center in downtown Sudbury. And I'd like to welcome you to this wonderful event. Thank you, Amira, for putting on this global event that we can be part of. And thank you also to our partners, NORCAT, for allowing us to be part of this as well. So over the next hour, we're going to be showcasing some of our technologies that we've been able to develop, and specifically Teleop Assist. So we'll be able to see a vehicle that's being operated at a mine about 50 kilometers from our location here in Sudbury. The operator will be in Sudbury, Ontario, with the machine in Onaping, Ontario at the NORCAT test facility, being operated both in teleoperation and using our semi-autonomous functionality of Teleop Assist. We'll also be showcasing some of our other technologies and different add-ons to that system and how they interact with each other to give an overview of the different technologies. So Hardline is primarily a technology company. We develop, design, manufacture, test, install, and service our products globally all over the world. We've been able to develop several technologies in both remote control and teleoperation and semi-autonomous and autonomous for various types of vehicles. We're actually 25 years in existence. We started in 1996, and over those years we've developed many things that we'd like to show you actually here today. So we started as a service company here in Sudbury, Ontario, and over the years we developed our own products. We were able to install these, again, all over the world on various types of equipment, whether it be remote control, tele-remote control, or autonomous operation in many applications. We started in Sudbury, Ontario, and that's where I am currently. We have two offices here. Our manufacturing and headquarters is based in Dowling, and then our technology center, which is fairly new, is in downtown Sudbury core, and that's where the development, design, and software development is being handled. In addition, we have offices in various parts of the world, including Salt Lake City, Utah for the United States, Santiago, Chile, and Lima, Peru, that handle our South American operations. And speaking of those offices, we'll actually hear from them right now.
My name is Angelo Verástegui y soy gerente general de Hardline Peru. Right now, we have over 200 systems working around the country, and we do the support for clients from Peru and other countries from Latin America. And at this moment, we have a similar situation with Teleop systems. Many people say that this is a good product, but the market is not prepared. It can allow us to work remotely, efficiently, and safely, but the market is not prepared. Well, my experience and that of my team knows that everything will look like impossible until it gets done. So, we are going to do the same as we did in the past. We are going to change the idea of the market is not prepared to be done.
Hi everybody, it's Brian LaRocque here. I'm the General Manager of Hardline Chile. We've been around here probably about 25 years. We've probably installed over 100 systems throughout Chile, anywhere from Chile Chico in the south to Iquique in the north, and all types of equipment. So we have a great team of people down here, technically fit. We have a good staff on hand, and I can only see bright things for the future of Hardline here in Chile.
Hi, my name is Chad Root. I'm the Vice President of U.S. Operations for Hardline USA, located here in Salt Lake City, Utah. We're located right next to some of the best mining complexes within the Western United States, and this allows us to support the line of remote controls, tele-remote controls, automation, and LP series of equipment that Hardline has to offer. Our employees are excited to be working with our customers and partners within the mining, construction, municipal, marine salvage, and airline support industries. So we look forward to continue doing this for many years to come.
Hi, I'm Lori Burke. I'm the Senior Printed Circuit Board Technician here at Hardline in Dowling, Ontario. I am responsible for operating and running the pick and place line that produces all of our printed circuit boards, which are used in our technology.
Hi everybody, my name is Patrick Roy. I am a service technician for Hardline. Here I am setting up Teleop in Northern Ontario. Good to go.
Thanks, everybody. Before we get into the presentation and we get to see the demonstration of the technology in action, we'd like to show a short video that showcases some of that technology and get perspectives from different ones in the industry and on the innovation and how this is transforming our industry. And then we'll get into showcasing the technology itself. Please enjoy.
The global mining industry has challenges they need to solve. Emerging technologies could potentially solve those challenges that the mining companies have.
If we look around the world, deeper mines are developing all over the place, right? So technology is going to bring us the capacity to operate without having to expose, personnel to difficult situations.
Keeping a very strong bond between industry and academia ensure that the courses that we offer are relevant. It also means that graduate students that we produce from our department have advanced level of skill in those areas as well.
As mines get deeper and get more complex, and as the machinery gets more complex, our technology allows them to be automated.
We have a huge supply of talent. We have leading academic institutions. We have engaged government that supports and cares about the future of the mining industry. Think of how Hardline is redefining what it means to have a job in the mining industry.
It's going to make it more efficient. It's going to make the industry more competitive, particularly the Canadian industry, which is where all these things are happening first.
I would say we could get at least 15 to 20% per shift if we can have that operator work in between while we're doing the gas clearing.
Opening up distributorship and partners in different parts of the world, being able to bring our product to everyone is really the goal moving forward.
You tackle issues with technology, you solve them, and you create value out of it. And that gives us the opportunity to be very comfortable and productive with the same amount of training involved. That's key for us.
So for the remainder of the hour of our presentation today, we're going to be looking at Teleop Assist primarily. So what we see here is our operator station sitting in Sudbury, Ontario. The machine, it will be in the NORCAT test facility or test mine, which is about 50 kilometers away as mentioned. We'll be operating that from this operator station and going over that network, running it in a semi-autonomous or Teleop Assist functionality. So we'll get a lot more into the details of that product line as the presentation goes on. NORCAT has been a phenomenal partner for us over the years. We actually rent a space at the NORCAT test mine, a drift that we use for our internal development, and it has been instrumental in developing our products thus far. We have a machine that we've purchased and put in the NORCAT test facility, which we're going to run today, and it's allowed us to go on site whenever we need to, not dealing with the restrictions that our customers face with production and on-site delays, but using NORCAT and partnering with NORCAT and having that machine available has been instrumental in our development. So we'd like to thank them for that as well. And today, that's where the machine will be located that we're going to look at. So what is Teleop then? As mentioned, it's a remote operating station, so this machine that we're operating has no one in the cab. There, in fact, is no cab on this vehicle that we're going to be operating today. The operator will be in this chair. All the functions and the controls of that machine are brought back to this operator station so that they can fully remote control it from a distant location. Teleop as a whole, currently, as mentioned, we're about 50 kilometers away. This can be installed on-site, on surface, underground, in a portable cabin or personnel carrier. It can be installed in a different office like we're doing today, about 50 kilometers away, or even large distances away as the need may be for operators to be further from the operation of the mine site. For example, one of our implementations that we've been doing in northwestern Ontario is a remote site where the operators have to travel in and out of the site, and the operator station is actually installed in an urban center where the mine site is not. It's only by fly-in travel, and it's allowed them to have the operators in the urban center and operate the equipment at the mine site, which is about 400 kilometers away from the operating station itself. So that was Teleop, our base system. Next, we'll be talking about our Teleop Assist add-on, which is an add-on to Teleop. Teleop Assist is a semi-autonomous system that is added to Teleop, and it enables the vehicle to drive down the tunnel or drift, minimizing damage to the piece of equipment. It uses LiDAR technology, 3D LiDAR technology, to scan its environment, to perceive its environment in real time, and make driving decisions in real time as the machine travels the tunnel. The operator is in control of the speed of the machine, the braking of the machine, but our assist system is in full control of all the steering functions of the vehicle, allowing it to drive at faster speeds and go with less damage to the equipment. So you've heard the explanation. Next, let's see it in action. Jeff Yoki, our Quality Assurance Supervisor, will be handling the demonstration and showing the functions of the system next.
Thanks, Ryan. So here I am in our downtown office, Technology Center in downtown Sudbury. It's a very comfortable space to be operating a scoop. I can tell you I'd much rather be here than underground. So right now I'm connected to a scoop in our test center at NORCAD underground, about 50 kilometers away from here. And on site there we have Marty, our automation support specialist. He's on site making sure everything goes smoothly on that end. The scoop that we use here is a pretty small one, so we had to tighten up the drift so that it could resemble a real life situation a lot more. So you can see that there's very little clearance on either side of this machine. It's running a very tight drift. So if I were driving this thing myself, in control of the steering, it wouldn't be pretty. I'd be scraping the walls, I'd be bumping the walls for sure, I can tell you that. So what our assist feature does is it's taking care of the steering for me. As you can see, one hand on the joystick controlling throttle, and that's it. That's all I have to do. And the assist will keep this machine going straight down the drift. It'll articulate itself, keep it centered, and I really don't have to worry about much more than telling it how fast I want it to go, or whether I want it to turn left or right at the next upcoming turn. Another thing that I really like about this system too is our cruise control. That'll simplify things even further. I can engage cruise, and at that point I don't even need to be telling the machine how fast or slow. Literally I can have my hand off the joystick, it'll be controlling speed, it'll be controlling steering, and when I get to a particularly difficult corner that I know is coming up here, I can just back off on the throttle a little bit. I slow the machine down just so it can give it a little bit more time to make that corner, and when I know it's past that bad corner, I let go and cruise will put that throttle back up and my machine will pick up speed again. So I'm about to drive this scoop through our course. We've narrowed it down. It's very tight, there's very little clearance on either side of the machine. And as I get going, you're seeing I'm heading straight into a T, straight wall ahead of me. So I don't need to steer that machine myself. It would be very difficult. I'd be hitting the wall for sure if I did. All I need to do with assist is say, I want you to go right. So I'm going to head up forward, and you'll see that it navigates that turn way better than I ever could as an operator. And the machine takes off right around that corner, no sweat. Now as I drive through the drift, it's one hand on the joystick. I don't need to be steering. Assist is doing that for me. All I got to do is give it a little bit of throttle, and it will make the turning decisions for me as an operator, keep my machine centered. So that was a little demonstration of our Teleop Assist. You can see it's got a lot of benefits that make driving easier for the operators and reduce machine damage. But Assist is not our only product. We've got a lot more to offer on our Teleop and our Teleop Auto lines, each with their own benefits that will target a different aspect of the mining industry. So Ryan's going to talk a little bit more about that now. I'll pass things back over to Ryan.
Thank you very much, Jeff and Marty. So next we're going to go to the operator station and actually show some of the extra additional upgrades to Teleop, including the system's touchscreen interface, login menu, control station functions, as well as the Teleop Multi and Teleop Auto. So now that we're in the Teleop operator station, we can walk through some of the additional add-ons or other features of Teleop. So here, when an operator sits in the Teleop operator station, they would be at a login screen. So every operator has their own unique username and password that they would use to log into the system. So once they do that, they would need to select the vehicles that they would like to control. So we'll first talk about Teleop Multi. In Teleop Multi, we can see here on the screen that there's various types and numbers of vehicles, different types, different makes, different models of vehicles that can be operated from the Teleop operator station. And here we're going to select 2 vehicles. We're going to select one underground LHD. And the operator here is presented with a series of pre-operation questions. So these can be customized on a per-site basis or even a per-machine basis with specific questions that that customer would like the operators to answer. So after answering these in correct answers, they could be yes or no questions, but after they answer them correctly, it allows that machine to be operated. Next, we'll add another vehicle. So notice I added an underground LHD. I'm also going to add a dozer. Here, it's presenting with what work zone that vehicle is going to be operating in for that day. And the same thing, there's questions about that specific vehicle, about that specific area that need to be answered correctly. Once they've selected the vehicle that they want to operate for that shift or for that time, they would hit the start button, which would load them into the operation side of the Teleop system. After the operator would get into the system, they're presented with our post-operation questions, where they would need to answer these questions. They're linked to the vehicle, so these are questions that they may need to have operation of the vehicle to get the answer for. For instance, a brake test. This is where a brake test would be performed, and the operator would be able to answer these questions, and again, these are customizable per vehicle and per site. So they would answer these questions correctly, and that allows them to operate that vehicle now. Switching to the other vehicle, we have the same questions that are required to be answered for that vehicle. So to highlight the main features and benefits of our Teleop multi-system is here we have an underground LHD that's set up for Teleop Auto. It's in the level, actually at the Facunas mine. We see a 3D map of the Facunas mine here. And the controls that are on the screen currently are for an underground LHD. The functions on the joysticks are all generic for any vehicle. So whether it's a bulldozer or an excavator or rock breaker or a locomotive or an underground loader, all of the functions of the joysticks can be used for any vehicle. And we can see here that this screen shows us what all the joysticks and functions do for the specific vehicle that we're controlling currently. If we switch to the other vehicle, we see that all of the functions for the joysticks for that vehicle are shown now on the system. All of the functions of the joysticks are now mapped to different functions for the specific vehicle, being a dozer or a loader. We see that on the screen in front of us here as well. All of the functions specific to a bulldozer update automatically for the throttle and park brake and ripper functions and whatnot that would be specific to a surface bulldozer. In addition to that, when we switch between vehicles, all of the video feeds and the telemetry information that comes back from the vehicle, all of the alerts that come from the vehicle, all switch automatically for the operator. We see on the screen currently is a telemetry for underground LHD. Switching to a dozer, we see all the telemetry updates automatically to the telemetry for this specific bulldozer. So that's our Teleop multi-system, is the ability to have multiple vehicles, multiple types of vehicles, multiple different numbers of vehicles, all controlled from one specific operator station. Next, we're going to look at Teleop Auto for underground LHDs. And here we see an underground LHD in the Norcat mine where we were just operating our Teleop Assist system from, but now we're in full autonomous mode. So with Teleop Auto, the steering, braking, throttle, all the decisions are made from the Teleop Auto system and not from the operator themselves. They would put it in autonomous mode, and then it's very much hands-off after that. So here, again, we see our vehicle. We have areas where the vehicle is allowed to drive and areas of the mine where the vehicle is not allowed to drive. There's paths that it's predefined paths that the operators that need to be added to the system so they can run in that area. So I'm going to start our machine now. We will release the park brake, allowing the vehicle to drive.
Auto engaged.
And now we're able to engage auto on this vehicle. The vehicle is parked right here. We see the driving line that it can drive on. At this point, the operator is able to either select predetermined areas where the machine would drive to, for instance, the 1998 face, turnaround, gate. They can select that from this menu and
Driving started.
start the driving that way. Or if there's no predetermined area where the machine is selected to go to, if it's in the middle of an area, then the operator can select that easily as well. So to show that, we'll stop the driving and select a spot along the route that the vehicle will drive on.
Driving started.
So as mentioned, with Teleop Assist, there's very little setup time. It's very quick to set up, very quick to move from level to level. With Teleop Auto, there's a setup that's required for the vehicle to be able to run autonomously in this zone, which is a 3D mapping process that happens. But again, it's very hands-off for the operator, where all the functions are autonomously controlled or automatically controlled for the operator. In this instance here, we see that the vehicle needs to be pointed a different direction at the other side of the map. So we're required to enter a turnaround point where the vehicle has to pull into, turn around, and then continue driving in the other direction to arrive at the destination in the right orientation that's required for this specific application. And this can be completely customized on a per level, per machine basis. The next function of Teleop that we wanted to touch on is the ability to control or read sensors from auxiliary devices that might be involved in the system. So we have our general purpose input-output modules, which we're going to talk about more in just a second. But from the operator station here, from the GPIO screen, we see here that this operation for this level is set up with these specific outputs and inputs from other modules that need to be controlled from the system. So these can be set up as momentary buttons, as on-off buttons, or as even scripts. If there's fully autonomous functions that need to happen that are very much scripted, that never change, that are static in every way, these can be set up to run a script of functions in a predetermined order to either open doors or close doors or turn on water sprayers at certain times in the cycle or whatever that might be. So that's all configured through the system to be able to control that from this screen, from the GPIO screen. So any Teleop system that's installed, Teleop Multi, whatever upgrade they might be, these are installed. Every entrance to a Teleop zone has one of these installed that notifies the system if somebody was to enter a Teleop enabled zone. So from these connectors, we would connect to either a physical gate that we would install or a light barrier, light beam that would be installed across the tunnel or area that they're kind of coming into. And if anything breaks that beam, this device notifies the system that that's happened and issues an e-stop to any vehicles that are in that work zone. There's a local e-stop that's connected here, as well as a way to lock that e-stop in place if required. And so it uses a local e-stop or an external input to let the system know that somebody has entered or potentially entered that area. In addition to that, it also functions as a general purpose input-output module or GPIO module. So these additional connectors that are installed on here, they can be connected to other devices that we might need to control in the mine site. So a lot of times in an application, there's going to be a machine that has to dump in an ore pass or get loaded from something, or in applications with LHDs, there's water sprayers that are required to wet the ore that they're pulling out. in the area. So these devices are installed so that from the teleop operator station, they can turn on and off these auxiliary devices that need to be controlled as part of the system. So inputs from sensors, inputs from light beams, inputs from other types of devices that might be involved in the total teleop package would connect to here, as well as our barriers. And one of the big differentiations, benefits of teleop is this GPIO capability. For sites where the machine is automated or machine is teleoperated, it doesn't help a whole lot if somebody has to manually open a vent door or open an OR-pass door that the machine is dumping into. So with teleop, with these GPIO modules from the operator station, they would open and close these all seamlessly, all tied into one system. It's very much a whole package, a whole solution for remote or autonomous operation. So that was an overview of our teleop suite of products: teleop, teleop multi, teleop assist, and teleop auto. In addition to that, we have many more innovative products that we'd like to show you. So I invite you to look at our website, www.hard-line.com. And in addition to that, we have several social media, including LinkedIn, YouTube, Twitter, and Facebook. So we invite you to follow us on our social media as well. We have case studies, we have different events, different information about events that we share on there. So please follow us on social media. We'll be going to a Q&A session in just a moment, but before that, there's one more video that we'd like to show you. This one is geared specifically more to our teleop line of products and various information about that. So we'll do that, and then we'll throw to some questions and answers.
This company has actually developed something that's pretty unique.
So the impact is big.
When the company started, what the vision was to build a better radio remote control system. All the systems that were available had been adapted from other industries. They hadn't been specifically built for the mining industry.
Research and development is a huge part of what we do. We're an innovative company, and we do strive to push new innovative products all the time.
We're not a systems integrator. We design those boards. The real-time operating system is our operating system. All of those types of things give us a finished product that we have total control over.
The teleop is the core of the whole system, so it's where everything starts.
Teleop system is hardware agnostic. It means we can put it on any vehicle, any year, any model.
The truck that's driving across the level, we can automate that truck across the level. The rock breaker that it feeds onto, we can run that rock breaker from the system.
The other part of the scenario is you have to increase productivity safely.
Teleop system allows them to stay on surface, gets that extra production out of the mine site, keeps them out of danger.
And that's been our goal, is to continue to put innovative products on the market forever.
This is changing the way business is done.